Hello and welcome everyone. Please share this session to each and every one of your friends, colleagues and every Telegram group, WhatsApp group, whatever you have. Good evening Ravneet, very good evening. So this is English, my 10 questions of heat transfer. So today's flavor will be moderate questions, not too damn lengthy, but yeah, moderate level of questions. Tomorrow again you have my 10 questions, but 11 a.m. in the morning tomorrow. Okay. Namaskaram. Khush rahiye. Good evening. So please share this session to everyone. Kindly share it. Also, Sai, do one thing. Please share it in my Telegram channel as well. I'm still not able to access my Telegram channel, so please share it amongst my Telegram channel students. Please do it. Right? I'm good. Thank you for asking. The subject is heat transfer, HT. Today we are going to discuss heat transfer. Tomorrow again heat transfer, but that will be in Hindi. Different 10 questions, 11 a.m. Okay, same heat transfer subject, but different because language is different. So there we'll study different questions. In this, different questions altogether. Okay. So please share it everyone. Kindly share this session. And also tomorrow there is discussion of PI paper also, right, on both the channels, English as well as Hindi channels. We'll be dealing with that. Very good evening, Neeraj. Very good evening. Please share this session everyone. Kindly share it. We are going to move forward with this. Shared? Okay. So one by one questions will be given to you. Same old pattern. I'll be giving you 3 minutes to solve one question, and after that I'll be telling you the answer. All right. So here we go. First question in front of you. The time constant of a thermocouple is the time taken to attain. This question has been asked already, right? Many a times. You're feeling like because of the pressure building, right? I can understand. I can correlate. Anyways, your time starts now. It's a very simple question, very straightforward question. Possibility to be asked in a 1 marks thing. So please do it. Please do it. First C, right? Good. Fair enough. First C. Fair enough. So shall we start? Shall we start? Time constant of thermocouple is taken to attain. Please pay attention. If you forget this definition somehow, just do one thing. Theta upon theta I is e to the power minus tau over tau thermal. Am I right? So what is one time constant? So one time constant is basically one time constant or time constant when tau equals tau thermal. Am I right? Whenever tau is equal to tau thermal, that is known as your time constant. That is known as your time constant, of course. If that is the scenario, then theta over theta I equals e to the power minus 1, which is equal to 0.362, right? Or 36.2%. So it means that theta is 36.2% of theta I at this location, at this point. So at this point in time, the value of theta is 36.2% of theta I, initial temperature difference. That means it is the temperature to attain. 36.2% is remaining. So how much is attained? 100 minus 36.2, which is 63.2% of the initial temperature difference. Right? It has attained already. 36.8, my mistake. You are right. 36.8. और 2 लिखा गया. 36.8% of theta I. Is it clear? Is it clear everyone? Understood? Say yes or no. Shall we move forward? Tell me please. Shall we move forward? Simple straight away question. We always open with simple questions, right? Then we'll take the concepts to another level. Is it done? Moving forward, next question on your screens. Now, a metal rod of 2 centimeter diameter has a conductivity of 40 watts per meter Kelvin. K is given, which is to be insulated with an insulating material of conductivity 0.1. Convective heat transfer coefficient is phi. Critical thickness of insulated, it is written, sorry, insulation. This is very important. Why? Because 1 marks question have been asked many a times. You have to solve it. Please do it. Please do it. This is an important one because many a times questions have been asked from this concept. Please do it. One centimeter. 1 centimeter is it? Let's see. Let's see the solution. Should I start with the solution part? You might have tried, right? So always the thickness of insulation, because it is a metal rod, means it is a cylinder. And for a cylinder, please, you have to check this as well. Many a times what happens is it is giving you ball or sphere, and for a sphere the formula in order to find out R insulation critical is entirely different, right? So hence you cannot apply that of cylinder. So it creates a very big trouble. In order to avoid such things, what do you need to do? You need to simply check. So it is saying a rod is cylindrical, hence we'll use the formula of cylinder. Means R insulation critical of the cylinder is, that is 0.1 K insulation over H naught, that is it. K insulation is how much? 0.1 over, what is H naught, my dear? H naught is phi. Is it clear? This will be in meters, okay? 0.02 meters. Am I right? 0.02 meters or 2 centimeters, that is there. Now 2 centimeter is this, a metal rod of 2 centimeter diameter, means this is the metal rod of 2 centimeter diameter, means radius is 1 centimeter, and the radius of this is critical is 2 centimeter. 2 centimeter insulation. So how much is it? R insulation critical minus R naught is T insulation critical, thickness of insulation. So I think it is 1. Yes or no? That is your 1 centimeter. Many a times these kind of questions have been asked. Is it clear? Is it clear? Yeah, 2K by H is there for sphere, but it is a rod. We'll use that for, we'll use the formula for the cylinder only. All right, understood, guys? Tell me, guys, please tell me, is it clear? Shall we? Shall we move forward? Great. Next up, in a counterflow heat exchanger, the product of specific heats is same for hot and cold fluids. NTU is this much, then the effectiveness of heat exchanger. It's a simple formula based question, yet very much asked. So it is also important. See, let me tell you one thing. Please, I'm not giving you this. Listen to me. Today is 5th of Feb 2022. Sorry, 2022. Right? Tomorrow is 6th of Feb 2022. Today is heat transfer, my 10 questions, but this is based on gate pattern. Gate pattern and conceptual level is medium. Tomorrow, heat transfer, 11 a.m. These will be based on gate as well. But the conceptual level shall be tough, hard. Okay? Understood? Got it? शाम को मेन चैनल पर कौन सा है देख के बता पाऊंगा अभी नहीं I mean I'll tell you but later on. Yeah, so this is a simple formula. You have to tell me what is the answer. Counter flow na? Counter flow. Tell me guys, what is the answer? Do it please. You have 2 more minutes. Do it everyone. Only a few people are answering now. I want everybody's participation. Please. Is it done guys? No, it is not saying parallel. It's simply saying counter, right? If it were parallel, then yes, your answer would have been right. Anyways, effectiveness of counter flow 1 minus R e to the power minus NTU 1 plus R. Say yes or no. Please tell me 1 minus R. My mistake. Yes or no. Over 1 minus e to R times e to the power minus NTU 1 minus R 0. If since m dot has ch, m dot c cc, so that is equal, means R is 1. So if R value is 1, it means what? EC is of 0 by 0 form, and if EC becomes of 0 by 0 form, then what do? You simply take, if EC becomes 0 by 0 form, then it is very simple. What do you have to do then? 0 by 0 form, NTU upon 1 plus NTU. Am I right? That is your epsilon of counter flow. Put this into perspective, you will get the answer. Yes or no? I think it is 0.5, right? 0.5 over 1 plus 0.5. So 1 by 2 over 3 by 2. 1 by 3. That is 0.333. That's your answer. Understood everyone? Simple. Okay. Next question is from radiation. Two long parallel surface each of emissivity 0.7 are maintained at different temperatures, accordingly have radiation heat exchange. Okay, desire to reduce 75% of this radiant heat transfer by inserting thin. This is a problem which is based on 1 marks. 1 mark problem is there, right? What would be the number of shields? Number of shields required, again 3 minutes. Just try it out. It's a direct question. It's a direct question, right? Focus on the language of the question, data given. You'll be able to understand what it is being asked. Kindly pay attention to the language. 3, 4, C. Okay. Yeah. Fine. See, there are two thin parallel plates. How to do, sir? We don't understand. Let me tell you. There are two parallel plates. Okay. I'm not deriving things for you. I'm just telling you. 1, 2. There will be a surface resistance. Am I right? Will there be a surface resistance? Yes. Here also a surface resistance? Yes. Will there be a space resistance? Of course, yes. Am I right? So, for this parallel combination or parallel plates, we have two different plates. Am I right? And if two different plates are there, two different resistances, three different resistances are there. Means there are two surface and one space. Now, same setup, I am inserting a shield in between. So, of course, there is R surface, right? And there is a R space as well. But since the shield is introduced, here one R surface is there. Here also one R surface is there, and one more R space is maintained. So it means that due to one shield, what would this one shield do? This one shield will introduce two surfaces and one space resistance. So if there are N shields, what would these N shields do? N shields will do that they will increase 2N surface resistances and N space resistances. That's what they are going to do. Yes or no? And you should know that the heat transfer rate with shielding is equal to Q without shield over N plus 1. That is what is there. But it is the only condition when upsilon 1, upsilon 2, upsilon 3, upsilon shield are all equal. Am I right? If all these upsilons are equal. Understood? That is why this is there. N plus 1. N plus 1. So if this happens, by what percentage do you need to decrease? 25%. So it means that Q with shield must be without shield ka 25%. Am I right? And 25% will be remaining only if this N equal to 3. Only if N equals to 3. That is N plus 1 becomes 4, and 1 by 4 is 25%. 1/4 is 25%. Understood, everyone? Is it clear? Yes or no? This is your shielding concept in radiation. Okay, guys? Understood? Say yes or no. Done? Shall we move forward? Next. A cylindrical or a cylinder uranium fuel rod of radius 5 mm in nuclear power plant. Radius is R equals to 5 mm of the rod is generating heat at a rate of this much. This is your QG. The rod is cooled by a liquid with convective heat transfer coefficient of H. At steady state, the surface temperature T surface is what? Please take 3 minutes of time, try and do it. Okay, please take 3 minutes of time, try and do this. Then we'll do it. I told you I won't be wasting much of your time. Okay, that is my primary motto. Because you only have a limited amount of time left now, and I don't want to waste just to increase my watch time. Okay, I don't need to waste your time. I'm not that selfish. Please do this. Is it B? Is it B, dear all? Last 1 minute is remaining. I want more answers, more people to participate. We'll see what the answer is. So, okay. B, great. Just a few more seconds. These all are 1 marks questions. Today, more or less 1 marks questions. Every question. Okay. Fine. Let's do it. Cylinder uranium fuel rod of this much means this is a fuel rod. All right. And my dear students, this is your radius. What is it? 5 mm. Great. 5 mm. And heat is being generated at 40 megawatt per meter cube. Can we say that? Just to write it in a more understandable perspective. If it becomes 40, it becomes 10 to the power 6. 10 to the power 6 is mega. We know that. Anywho, so heat transfer coefficient is 1000 watts per meter squared Kelvin. And what about the length? Okay, no problem. We don't require it actually. Trust me, we don't require it. What is the 25 degrees Celsius? No problem. So now at steady state, steady heat transfer condition, what do we get? The rate of heat generation must be equal to what? The rate of heat dissipation or convection, or heat dissipation by convection, whatever you want to say, you can say. Understood? हाँ, वो cancel हो जाएगा. So, I'm very happy that my students are performing well. Acha, let me ask you this thing, and please tell me honestly, was the course on heat transfer useful which I took on this channel? Surface area times delta T. Please tell me, guys. I really want to hear it from you. So it is basically 40 times 10 to the power 6 times pi r square L, pi r square L, right, equals H is 1000 times 2 pi RL. That will be your surface area, 2 pi r into L, times TS minus 5. Pi is gone, R is gone, R is gone, 1 R is remaining. 1, 2, 3, 3 is remaining. So it is basically how much? 40 times 10 to the power 3 times 5 times 10 to the power minus 3. 5 mm is there, no? 2 TS minus 25. Great. Now, so this is gone as well. For what is this? How much is this? If you calculate it, it will be 40 into 5, 200. Am I right? 40 into 5, 200 divided by 200 plus 25 is what? TS. So TS is 125 degrees Celsius. If you want to convert it into Kelvin, 278 plus 100, 398. Sorry, 298 plus 100, 398. Understood? Good. चलो बढ़िया है. चले आगे. Shall we move forward? I'm very happy. At least I have brought about some changes in somebody's life. That's what I have done. And that makes me happy and sleep sound, to have a sound sleep in night. Please do it. Done, my dear lovely students. Take a screenshot. Just do that. Take a screenshot. Moving on. So this one, water flows through a tube of diameter 25 mm at an average velocity of 1 meter per second. It is 1 meter per second, right? The properties of water are rho, mu, K, PR. Using Nusselt number, this is given as well. By the way, this is Dittus-Boelter. No. Yes or no? Dittus-Boelter equation. The convective heat transfer coefficient, H, you need to calculate. Please do it. Take 3 marks. It is very much probable to be asked. Please do it now. पोल बाद में खेल लेना. Do it first. Take 3 minutes of your time. Do it. Hmm. 2399.1. Everybody got this? Okay. Two three nine 9.1. Great. Let's see. Solution. Do you know h bar L by K is your Nusselt number, and which is given as 0.023 Reynolds to the power 4 by 5, which is 0.8 basically, Prandtl to the power 0.4. That is your formula. So what about h bar? H bar, if you want, you have to calculate. That's clear. Water flows through a tube of diameter. So what is the, if water is flowing inside, 4 times area of cross section upon wetted perimeter, that is the value of LC. So 4 times pi over 4 into d squared over pi d. So d is remaining, am I right? Diameter, right? So that is your 25 mm na, 10 to the power minus 3 over K. What about K? Thermal conductivity. 0.325, 0.325, am I right? Equals 0.023. Reynolds is rho Vd by mu. Rho, let us calculate. 1000 kg per meter cube, am I right? So it is water, of course, it is given as well. Rho V 1 V LC. How much is LC? Okay, what is LC? We have calculated, na? 25 mm. So 0.025. Directly I'm writing, right? Rho Vd by mu. Mu is 7.25 times 10 to the power minus 4. Great. And to the whole power 0.8 or 4.5, whatever you want to say. And this one is 4.85 to the power 0.4. So now your h bar shall be coming out, and let's see how much is it. नहीं तो ये रिलेशन याद नहीं रख पाओगे. Won't you be able to remember this equation? It is very simple यार. आईआईटी वालों को कृपा करने की क्या जरूरत है, आप उन पे कृपा करोगे, याद रख लोगे. This equation is very simple, dude. This equation is really very simple. To the power 0.8. 4266.6 is your Reynolds number. 4.85 to the power 0.4. 0.023. 0.325. Okay, divided by 25 into 10, 1000. 2399.1. Watts per meter squared of Kelvin. That, my dear students, is your h bar. Okay. See, turbulent in general in gate examination is not asked in that much depth. So all you need to do is you need to remember this formula. If for turbulent, just you need to do is you need to remember this formula. That's all you need to do. That's all is required. Understanding? You need to simply remember this formula. That's all is required. Got it? Do it, please. Try and remember only a few formulae. That's all. सारा टर्बुलेंट का सबका बताया मैंने. Okay, shall we? Next, a counterflow heat exchanger is employed to cool this much mass flow rate, that much specific heat from this much to this much by the use of water. Inlet and outlet temperature of cooling water are this much. It is simple, very easy question. 1. I am very, very much honored by this, Neville. You will be cracking those subjects, trust me. And I have very much faith that if you guys have learned very, very, very carefully for the whole year, you will be able to score 100% in my subjects. Trust me. Right? Try and do this question. Then we shall be moving forward. Just 2 more minutes. I'll give you all. Try and do it. Today, I am telling you, I have taken only 1 marks questions. All questions are 1 marks questions. All of them. Okay? Just 1 marks questions. Tomorrow, the level of questions is going to be good, and be prepared, guys. You are going to enjoy tomorrow's class on a much different level. B, let's see. So this one is simply energy balance. How? Let me tell you. This is based on heat lost by the hot fluid, which is oil, equals to heat gained by the cold fluid, which is water. Am I right? So let's see how much heat is being lost. 0.55 means m dot into Cp of oil into delta T, T oil inlet minus T oil exit, equals m dot Cp of water, T water exit minus T water inlet, because water is being heated up, that is why. So what is m dot? 0.55, no doubt. How much is this? 2.45. Now, what about OI, oil at inlet, from 115 minus 40 equals m dot, we don't know, W. Specific heat of water is 2.45. Sorry, 4.18. And this one is 75 minus 15. So you have m dot of water. Please calculate how much is it. Is it coming out to be B? 0.4. So it is B, 0.4 kilogram per second. Is it the case? Yes or no? Means 400 grams per second near about. Yeah. Actually, I have talked to some of the faculty members, my fellow colleagues, and they said that although MSQs were more, but the thing is, the level of questions was easy in their perspective as well. And this is the habit of Kharagpur. Whatever changes are made in the syllabus, they employ. So this year you also believe me that you guys will be having some more MSQs as compared to previous year. Previous year there were no MSQs actually in mechanical. So this year might be. 15 MSQs were there. 15 MSQs and 13 around around 13 were there. NETs, and rest were MCQs. Exactly, they don't have negative marking. Anyways, shall we move forward? 13 NET. Next question. Which of the following statements is wrong? Directly. Thermal conductivity of a gas increases with increasing temperature and decreasing molecular weight. The larger the thermal diffusivity, the faster the heat propagation. Hat nahi. Thermal conductivity of substance is highest in solid phase and lowest in gaseous phase. Thermal conductivity of liquids is insensitive to pressure near critical point. लिखा रहेगा. Whenever MSQ question is given, MSQ is mentioned. Got it? It is mentioned in general. Till last year they were mentioning it. Getting my point? हाँ, ये MSQ लग रहा है. Why MSQ लग रहा है? हाँ? 8th is D, है ना? It is actually insensitive. Please check. Of course, thermal conductivity of gases is proportional to root under R bar T by M. Yes or no? So it increases as temperature increases and decreases as and also increases as we decrease the molecular weight. Of course, it is right. Larger the thermal diffusivity, faster the heat propagation. Exactly. That's what happens in case of air and water. If we do the comparative study, which we have done already, so the thermal diffusivity of air is more, although its thermal conductivity is less. So we have seen that. Hence, this is correct as well. Thermal conductivity of substance is highest in solid phase and lowest in gaseous phase. Thermal conductivity of substance is highest in solid phase, exactly, because lattice vibrations and electron transfer will be there in solids only, not in case of gases. And this one is wrong, which is the correct option according to the wrong statements. And if, see, this question will become MSQ if it asks which of the following statements is correct. It becomes MSQ. Okay? Understood? If it says which of the statements is correct, it becomes MSQ. That's the basic difference. Understood? So no need to worry about MSQs. If you have a strong grip on your concepts, nobody, let me tell you, is ever going to cut your marks, or no concept is ever going to cut your marks out. Got it? Understood, everyone? Shall we move forward then? Clear? This I have taught you why it is there. Please see it in this perspective. If you have a larger gas molecule, means size is more weighted it is, like carbon dioxide and all. Understood? D को थोड़ा explain करेंगे, मैं करता हूँ. I'll explain it. But before that, let me tell you this. What happens when you have a molecule which is not lighter in weight, but which is heavier? Capital M is more. So whenever capital M is more, what happens in that case? Whenever capital M is more, in that scenario, inertia is more. So it requires more energy to move along. In order to change its state, it requires more energy at molecular level. So its thermal conductivity is less, right? Because in gases, it is due to molecular collisions only. Got it now? Understood? Now, so in this, thermal conductivity of liquids is insensitive to pressure near critical point. The reason is, whenever you see critical point, at this point, there is not much difference between what? Gas and liquid. Why? If you see the PV diagram, I have told you, pure substances I have taught. Remember, if you see this PV diagram near this critical point, there is not much difference. Is it clear? Is it clear? So it means that it is not varying much with respect to pressure. The variation is not much with respect to pressure. Getting my point? Understood? I have told you this in thermodynamics, right? Plastic pipe, thermal conductivity carries a fluid. overall heat transfer coefficient. This is also a concept from where 1 marks question can be asked. All these I am telling you, these are for 1 marks. Tomorrow 11 a.m. we'll talk about questions carrying 2 marks. Okay. Good evening dear. 3 minutes. Take your time. Do it. Done guys. 34.71872 something. Okay, let's see. A plastic pipe of thermal conductivity K carries a fluid such that the convective heat transfer coefficient is this much, means H inside. Average fluid temperature is 100 degrees Celsius, T infinity 1, and pipe inner and outer dia di and d naught. These are overall heat transfer coefficient based on outside area is, right? So based on outside area you need to calculate. Let us see. Please check. Only inside conditions are to be taken care of. That is, we are only concerned with this. Outside, okay, atmosphere is there, temperature is there, but we are not concerned with that. Are you getting my point? Only the fluid which is flowing inside, we have to consider that. So if you check in general, 1 by ui ai equals to T infinity 1, Q equals to U naught A naught, because it is asking on the basis of outside area, T infinity 1 minus T infinity 2. Great, no problem. And Q equals to T infinity 1 minus T infinity 2 over 1 by U naught A naught. Okay. Either you can remember the formula and based on that formula you can go as well. Getting my point? But यही तो कला है, बाकी सब विज्ञान है मेरे लाल. T infinity 1 minus T infinity 2 over 1 by HI AI. AI is how much? 2 pi or pi dl. Great, no problem. And after that plus ln, what is it? R2 by R1 or D2 by D1, right? D2 by D1 upon 2 pi KL. Now many people will be confused, sir, what about H naught? If it is not given, don't take. Arey Baba, if it is not given, don't take. Understood? Means 1 by U naught times 1 by U naught equals to equals to, it will be 2 pi or pi d naught L into 1 by hi pi dil plus ln d2 over d1 upon में 2 pi kl. Is it right? Now you can solve. Now you can solve. Understood everybody? 62.89, is it coming out? 62.89, is it coming out? We don't require outside. If it is not given, then only it is considering this one. Right? Might be some perfect insulation and all this given outside. We don't have to consider that. Is it coming out to be 62.89? Please tell me, my dear students. Please tell me, everyone, yes or no. Got it? Great. That is your U naught. Length, if it is not given, take 1. Length, if it is not given, take unity. I have told you already. Yes or no? See, haven't I told you, whenever length is not given, what do you need to do? You need to take length as unity, of course. Yes or no, guys? Please tell me. Or even if you don't want to, you know, acha, if you multiply it, is there any need? Three marks. 3 minutes. 1 marks. Do it. This is a good question. Try it. Think. NTU value is not given, no? 2.5. Okay. Is. Okay. Calculate for 2.5. NTU value 2.5. My mistake. It was not mentioned. I mean, the typist did it. Do it, please. $50. Okay. D. Samarth is getting D. Anyone else? $50. Sumedh is also getting. Happy I am. Very happy indeed. These two people have done. See, so the time is up. Let me do it. What is effectiveness of upsilon of parallel flow count heat exchanger? 1 minus e to the power minus NTU 1 plus R. Yes, over 1 plus R. So please check if this value of R is less overall minus, effectiveness is more. So if R equals to 1, then only effectiveness will be minimum. Why? You understand? Upsilon to minus this. If it is let us say if it is adding 0.2, then 0.2 is less than 0.5. Let's say one time it is 0.2, one time it is 0.5. So when it is 0.5, with respect to that, when it is 0.2, it is lesser. So overall minus will be lesser and effectiveness will increase. I hope you understand. So it will be minimum only if R is maximum, that is 1 minus 2.5 into 1 plus 1 over 1 plus 1 means 1 minus e to the power minus 5 over 2. Is it coming out to be 50%? Is it coming out to be 50%? Please tell me yes or no. Yes or no. I told you today's questions will be completed within 1 hour. I have fulfilled my promise. You can check for yourself. Understood everyone? Yes or no? Today's my 10 questions are completed within 1 hour. I don't want you guys to make any of these, commit any of the crime which is, leaving the paper and wasting time. Okay guys, so this is it for today and thank you so very much for joining. Please tomorrow 11 a.m. be available. Tomorrow's session is going to be on next level. Okay, आज शाम मेन चैनल का सब्जेक्ट. जस्ट अ मिनट, लेट मी टेल यू. जस्ट अ मिनट, लेट मी चेक. इन माई मोबाइल फोन आई हैव दिस लिस्ट. वेयर इज इट? कहाँ हो तुम, कहाँ हो तुम? Production by Deepraj sir, it says. Let's see. Okay. Fouling resistance and inner overall heat transfer coefficient is given. Then how can we find outside heat transfer coefficient? If fouling resistance is given, you can find out fouling factor, sorry. Right? And there's a formula: 1 by fouling equals to 1 by U minus 1 by UI, dirty and clean. That's how you can do. Okay guys, no, it is old phone. It is 1+7. My father used to use that and gave my father iPhone 13 and I took his phone. So he's using that, I'm using this. Okay, chalo. All the very best to all those who are writing PI paper tomorrow, and we'll be discussing that as well. Bye bye, take care. Jai Hind, love you guys. It's a pleasure. Bye bye.